So welcome everyone. We are so excited to have Miss Dixie Ross with us this morning, calculus rock star. welcome. Um, so today I'm just going to go over a few slides with you guys before we get started. Very brief, just a few reminders. While this online review session is intended for a Kentucky audience, of course, we welcome students from all other areas. Here's some information for you. You can follow Advanced Kentucky on Twitter at Advanced Kentucky. I am Melanie Gray from Madison Central High School right here in Richmond, Kentucky. You can follow me on Twitter at Calculus Queen, C-O-W, Calculus. There's my email address as well. Meeting etiquette, just microphones off, video off, but by all means, feel free to drop questions in the chat. I'll be manning the chat for Miss Dixie and letting her know of any questions that anyone might have. And we really encourage that interaction and welcome that. So recordings, links, and handouts can be found here at the bit.ly that you see on this slide. Also, all the past recordings. So this is our grand finale. As you guys will be taking your test, the students will be taking their tests on Tuesday, but we are also very happy to welcome all the teachers in the house today. Thank you so much for joining us, teachers and students alike. Here's more information. Again, our email addresses, information for the handouts and recordings, and following on social media. So without further ado, I'm going to hand this thing over to Miss Dixie Ross.
Okay, guys, good morning, and thank you for being here. This is a wonderful way to spend a Saturday morning. And after we get done here, I hope that you will then go outside and enjoy a beautiful day. The weather here is fantastic. I'm not sure what's going on in Kentucky. I'm down here in Texas, and we had some pretty severe storms the last couple of days, but now it's cleared up and we're gonna have a fabulous weekend. So again, we really thank you guys for being here, and we hope that we're gonna provide some really good information to you. As Melanie said, like, type in the chat, you guys, if you have a question, and she'll, let me know, because I probably won't be seeing the questions in the chat myself. Today is Derby Day, you guys. Derby Day up in Kentucky. And so I was going to wear a funny hat and I forgot. So we're going to have to make do without a funny hat. This first session, we're going to be talking about various applications of integration, but we are going to, we're going to also include some other things, because this is the final review session. I decided to make the problems that I'll be working today a little bit more reflective of what you'll see on the AP exam. And to some extent, the nice thing about our exam is that it's highly predictable. We sort of know what to expect. We're going to go in and we're going to do our 45 multiple choice. On the first 30, of course, those are the non-calculator questions. That's where they're going to find out if you can do derivatives by hand, integrals by hand. And then you're going to see, another 15 questions that are the calculator active. But remember, out of those 15 questions, you actually only use the calculator on about 6 or 7 of them max. So a lot of them are what we call calculator neutral, and they're testing your conceptual knowledge of calculus. Do you really understand what an integral is? Not how to take one, but what it is. Do you really understand what a derivative is? There'll be a short break in between the multiple choice and the free response sections, and then you're going to be hitting the free response. And so in this first part of today, I'm going to be focusing on free response type of questions and how you're going to construct your answers in order to get maximum credit. During the second part of this, so we're going to, I'm going to talk for almost an hour, a little bit less, and then we're going to take a very short break, and then we're going to come back and we're going to be focusing more on area and volume at that point, and we'll have a lot more calculator usage. So I'm hoping that you have the calculator that you're going to be using when you take the exam on Tuesday, because I think you really need to practice using that particular calculator. So as I said, you do the multiple choice first, there's a short little break, and then you head into the free response. For 30 minutes, you use the calculator for questions 1 and 2, right? And those are calculator heavy free response questions. And then after, your 30 minutes are up, then you move on. The proctor says, put the calculator down. And now you can work on any of the 6 questions. You can keep working on questions 1 and 2, you guys. You can stay there. But if your timing is really good, right when the proctor is saying, put your calculator down, you are finishing up question 2 and moving into question 3. Remember, you should spend about 15 minutes on each of those free response questions, right? If you're finishing in 10 minutes, you didn't try hard enough, okay? If you're taking like 20 minutes, that's too much time on one question, you guys. Don't allow yourself to get stuck and spend too much time on a question, because that might prevent you from actually getting to the very end. And what we know is question 6, we always try to incorporate some pretty easy points there. You want to get to question number 6. If you find yourself getting stuck or frustrated at question 4 or 5, keep moving, you guys. There's some easy points in front of you. Keep going to get to those easy points. Okay, so to get us started today, let me share my screen. And sometimes I think I'm sharing my screen and I'm not. Just like sometimes I think people can hear me and I'm muted and I'm talking, and students are frantically waving at the camera trying to let me know they can't hear me. So Melanie, can you verify that you can now see a graph on your screen? Okay, so.
Oh yeah, we can see it.
Okay, great. So what we know is that there's going to be one question that is what we call graphical analysis. You're given a graph and you're going to be answering questions based off that graph. Now it can show up, out of any of the 6 questions, but it's very likely to be on the non-calculator portion. So I'm going to start with this. And for this first problem, I've combined a graphical analysis with a motion problem, because we know there's going to be a motion problem, you guys. There's always a motion problem. There has to be. It might be one where they give you equations to use. It might be one where they give you a graph, or it might be one where they give you a table of values, right? We don't know the exact nature of that problem, but there will be a motion problem for sure. So what I've done is I've created a graphical analysis motion problem. And I'm going to ask you every question that I can think of that pertains to motion. On the actual exam, you would never have something with parts A through I. The most parts we can have is 4, right? We either have 3 or 4 parts on a free response question. So this isn't meant to mimic the style of the AP exam. It's meant to mimic the content of the AP exam. So when we see that there's 4 parts, like we don't really know what those specific 4 parts will be, but pretty much I'm going to cover all the possibilities right now. So we've got this graph. Make sure that you read the information. Sometimes there's a description. We can see that there are 3 line segments here and a semicircle, but we just want to make sure that everybody knows that's a semicircle. We keep going. The graph above shows the velocity of a particle moving on the x-axis. So this is the velocity graph. With position x of t measured in inches and time t measured in minutes. So my velocity units would be inches per minute. Let me put that down real quick. Now, if there's a motion problem and they don't mention units, you don't have to worry about units. But if units are given, you should try to give units in all of your answers, okay? So let's get started and see what sort of questions that we can ask based on this given information. Straight out of the gate, using correct units. Find the value of and explain the meaning of v prime of -4 in the context of the problem. So I tried to run off the handouts, you guys, so it wouldn't take too much paper for you. And so that means that I don't have a whole lot of space to write my answers. So I'm going to be writing them on a separate sheet of paper. Of course, on the AP exam, they're going to give you plenty of space. For every part of the question, they give you a half a page. Now, for some reason, you make a mistake or you just, you write super large and you need more paper, raise your hand. The proctor can provide you extra blank paper that they can tape into your test booklet. Okay, we're supposed to find the value of v prime of 4. Well, I know I have a velocity graph and a derivative would be the slope. So I need to look at the slope of this graph at 4. Sorry, v prime of -4. Okay, you know what's good is look carefully, because at v v prime of 4, my derivative does not exist. There's definitely a sharp turn there. But over here at v prime of negative 4, I can see it's just the slope of this line segment. So I can do the slope by counting. I can count up to and then right by 3. Up to, right by 3. So I'm going to say v prime of negative 4 is up to, right by 3. Then remember, I'm doing the slope or the derivative of the velocity. And so I can have units of inches per minute, or I know in physics, people like to write inches per minute squared. There's often more than one way to write things, you guys. And so anything that's correct is going to be acceptable. Okay, so we've got the first part done. And ideally, people understand this concept that, trying to focus a little bit better, a derivative is a slope, right? That's conceptual knowledge that everybody should have. Now we need to explain the meaning of v prime of negative 4 in the context of this problem. Now I have two good choices here as well. I don't want to say that it's slope here, you guys. I use the idea of slope to find this answer. But in the context of the problem, in the context of a motion problem, I could say v prime of 4 is the rate of change, because that's what a derivative is. It's a rate of change of the velocity in inches per minute per minute. Okay, that's a pretty good start. At t equals 4, negative 4 minutes. Okay, so this would be a really good explanation or interpretation of the meaning. A derivative is a rate of change, you guys. That's a phrase you should recognize. Rate of change of what? The velocity in this case. I've got the units here and I know the time. So this is a really good and complete explanation. Now, a lot of you are thinking, wait a second, the derivative of velocity is also called acceleration. You're right. And so acceleration would also work. And remember, as far as the units, you could put inches per minute squared at t equals negative 4 minutes. Now, writing out the interpretation should be pretty easy. But I'm telling you, I've graded thousands and thousands and thousands of papers. And most students don't get full credit on this, you guys. The thing that they leave out is they leave out the time, right? And so I have a little acronym to help me remember. I need to give them a noun, I need to give them units, and I need to give them time, right? People often use this word in reference to me. I'm not really sure why. I'm kind of a calculus nut, okay? Melanie's a calculus queen. I'm a calculus nut, okay? So noun, units, and time, make sure you give them that time factor. That's what students tend to leave out. All right, let's keep going. And as we go along, I'm going to be at various points reminding you about some formulas. Now, in addition to being a calculus nut, I am also a nut for Post-it notes. I like Post-it notes. They make me happy. And so whenever I see a theorem, definition, or formula that I need to learn, I write it on a Post-it note that I carry around with me in my pocket, and I post it on the mirror in my bathroom so I can look at it while I'm brushing my teeth, okay? And so that means first thing in the morning, I'm looking at it. First thing before I go to bed, I'm looking at it. And that way I'm slowly getting all these things into my brain. Okay, it's a way of memorizing things. And so one of the formulas that you guys should know already is the average value formula. So the average value formula is the one that looks like this. In my brain, to find an average, I add and I divide. Okay, this is an addition, right? That's a summation symbol. And then I'm going to divide. So from a to b, f of x dx, and then I'm going to divide by b minus a. I like to write it like this because I like to see the addition and the division sign. But the fact is, when I see this on the AP exam, it's going to be in this format. 1 over b minus a, integral from a to b, f of x dx. Okay, so this is how I initially learn it, but I know to look for it like this on the AP exam. So if this is a formula that you're not familiar with yet, you need to make yourself a Post-it note or write it on your hand, right? And walk around all day today, all day tomorrow, and get these formulas into your brain. We've still got 3 days before the AP exam. So stop and think about that, right? 3 days, you could probably memorize an additional, I don't know, 8 to 10 formulas or theorems. That's a lot of material that will make a big difference in your score. So as I'm going along today and I'm writing things on Post-it notes, you need to assess like, okay, I know that, that's good. I don't need to study on that. But you might see something where you're like, oh, that's what I need to study. So by the end of this session, I'm hoping that you've made a little stack of Post-it notes of things that you plan to study over the next 3 days. So we move on to part B of our question. And part B of our question says, using correct units, explain the meaning of this. Well, because of this format, like I can see that what they have here is 1 over 6 minus -3, integral from -3 to 6, absolute value of the velocity. Okay. I recognize this is an average value, right? I recognize the formula because I've seen it so often, right? It's on my mirror in my bathroom. I see it on a regular basis. So I know when I start explaining the meaning of this, I need to say, this is the average value of whatever this is. Well, the absolute value of velocity, you guys, is called speed. That's something that you need to know. Time for a new Post-it note. Boom. Speed equals the absolute value of the velocity. That's something that's important to know. And maybe you already know that. I hope you do. But if not, make a Post-it note for it. So this is the average value of the speed. I need units. Well, speed has the same units as velocity. Remember, it would be the same number. It's just that speed is always given as a positive. Average value of the speed in, what were our units? Inches per minute. And remember, that's where a lot of people stop, but we're not done. Between, or I could say from, t equals -3 to t equals 6 minutes. Okay, there's my answer. And now I'm going to double check it. Do I have a good noun? Do I have my units? And do I have the time mentioned? I do. That gives me a complete answer. Okay, so we're going to keep moving along and answering as many of these as we can. They only gave me an hour to talk about all of Unit 8, which doesn't seem like enough time, you guys. I could keep talking until the horses run today, you guys. But they only give me an hour. I got to keep going. Okay. So our next question says, find the displacement of the particle from t equals -9. Oops, hit my camera. To t equals 0. So displacement, that's a good physicsy type of word. And so do we know that the displacement is asking us to do the integral of the velocity from time 1 to time 2? That's how you find displacement. Okay, this is a vocabulary word that we should know. Some teachers just call it the net change in position. That's also true, but this is the word that you might see on the AP exam. So we need to be ready for their vocabulary, their way of asking the questions. Though this is also a correct interpretation of this definite integral. So the first thing that I need to do is I need to show them that I know that formula. Integral from -9 to 0 of the velocity with respect to time. So I need to show them the integral, and now I need to evaluate this integral. Well, I need to remember that an integral is basically a directed area. So I'm going to be going to this graph here, and I need to find the amount of area that's going from -9 all the way over here to 0. I see 2 triangles there, you guys. I'm hoping that's what you're seeing as well. This one is going to be negative because of the fact that it's below the x-axis. So I'm going to have a negative 1/2 of 6 times 2. Negative 1/2 of 6 times 2. Plus another triangle right here is going to be 1/2 of base of 3, height of 2. You're expected to know basic geometric formulas. You should be able to calculate the areas of triangles, circles, semicircles, trapezoids, right? Now, here's my answer. And notice I'm not going to do the arithmetic. I'm going to stop right there. This is what we call a safe stop. We do not want you to do the arithmetic. Okay? When you get to a safe stop, stop. Don't keep doing more math, because right now I have a correct answer. And if I'm going through a test and I'm feeling a little bit rushed, I'll make a mistake. Any of us could, right? So as soon as I get a good answer, I move on to the next part. That's part of my strategy for using my time effectively, is that I don't do any of the arithmetic. For two reasons. It saves me a little bit of time. And secondly, I'm avoiding arithmetic errors. Okay, next thing. It says find the total distance traveled by the particle from -9 to 0. Now, a lot of people don't know the difference between displacement and total distance traveled, because they look kind of similar, you guys. Let me put both of my Post-it notes up here. How do I get total distance traveled? Total distance traveled is also an integral from time 1 to time 2. There's a velocity involved, but I have to do the absolute value. So notice the difference in these. These are two different things. They both involve integrating velocity, but notice over here, because of the absolute value, you're actually integrating speed. When you integrate speed, you get the total distance traveled. Okay, so again, there's subtle distinctions here that some people haven't really keyed in on, and now's the time to really pay attention to these very subtle distinctions. Okay. So how am I going to get my total distance traveled? I need to let them know that I'm going to be doing an integral from -9 to 0, absolute value of the velocity. And then remember, the absolute value is going to make everything go positive. So this is going to be positive half of 12. I went ahead and multiplied 6 times 2 because I think I can do that. And this will be half of 6. And I'm going to keep moving. Because remember, that's the whole idea here. You have to keep moving. Now I keep moving along. They tell me if my initial position, if x of 0 is 4, find the position of the particle at t equals 2. Time for a new Post-it note. To get the new position, so I'm going to call this x of t sub 2. I'm going to do x of t sub 1 plus the integral from t sub 1, t sub 2 of the velocity. There we go. This is how I get the new position, is I take the initial position plus the change in position. Okay, I'm just checking to see if there's a question in the chat box.
Yeah, Dixie, I was going to...
okay. All right, somebody's asking a great question. How do we know what the safe stop is? The safe stop is when you have all numbers, right? When you have all numbers, something that you could enter into a calculator. Okay, that's the easiest way to say it. You could put it into the calculator and get a numerical answer. As soon as you're down to all numbers, all that's left to do is the arithmetic, then that's called the safe stop. Okay, that was a great question, you guys. And keep the questions coming. Sometimes I don't see them right away, but I do want to answer every question that you've got. So as we keep going along through the presentation, I'm going to mention, okay, now I'm at a safe stop and I'm going to keep moving along. So I'm hoping that you'll kind of see the pattern as we keep going, but it's basically once it gets down to arithmetic only, that's your safe stop. Okay, so we're getting ready to apply this new position formula here to this problem that we have. We're trying to find the position at time 2. We need to take the position at time 0 plus integral from 0 to 2 of our velocity. One thing that's really important to notice is that these numbers here should match, right? this number here matches that number because that's where you're starting from, whatever they give you. And this is what you're trying to get to. We're trying to get to a time value of 2. So they tell me my initial position is 4. I write that down. Plus, to get the integral, I need to go back to my graph. So here's my graph. And I'm trying to find the area from 0 to 2. Interesting. It's basically going to be this square here minus a quarter circle. Do you guys see my strategy? I'm using geometry to find that area. You don't always use an antiderivative to evaluate an integral. You need to understand that an integral is the area between a function and the x-axis on a given interval. That's an important thing that you need to understand. And usually if people have sat through a calculus course, they know that. So remember, my plan is to do the area of this square, so that's 2 by 2 or 4, minus the quarter circle. So 4 minus 1/4 pi radius, well, let's see, what's the radius? 2 squared. Safe stop, you guys. That's a safe stop right there because it's all numbers. And I'm going to keep on moving. Okay. The next part says, if x of 0 equals 4, when is the particle farthest to the right? So farthest to the right is really asking me for the maximum position. Let's see. So someone's asking me a question here. So I need to be careful. There is a minus on that. And so like if you wanted to simplify it, like that would be 8 and then minus 1/4 pi 2 squared. Okay. So I could do some simplification, but I'm not going to, right? I'm not going to do any simplification of numbers. As soon as I get something that's a numerical answer, I'm going to stop there. Okay. On this next part, I need to first understand what type of question I'm dealing with. When it says particle farthest to the right, what that means is maximum position. Okay. Maximum position is furthest to the right. Minimum position would be furthest to the left. We've got a particle that's moving back and forth on the x-axis. And so I'm trying to find a maximum position. And here's the thing I really want to stress. Whenever I'm doing a max or min problem, right? If you're doing max or min, you always set the derivative equal to 0. So the derivative of position is velocity. So I'm looking at this graph to see, hey, where's the velocity equal to 0? And I have 1, 2, 3 possibilities, and I have some endpoints here. So I want you to see how I'm going to develop my argument. Times positions. I'm going to include -9 because it's an endpoint. I'm going to include -3. I'm going to include 2. What is that? Is that a 5? Yep, I'm going to include 5. And then I'm going to include 6. And so anybody who's looking at my work is going to recognize that I'm doing what's called a closed interval or a candidates test. Now, a lot of you are like, hey, could we leave out the 2? Like, we could leave out the 2, right? Because 2, since your derivative does not change signs there, that's neither a max nor a min, okay? That's true. It's neither a max nor a min. So you're right. You could technically leave that out. But sometimes it's easiest just to go ahead and make a full chart with both endpoints and then any critical points that you see. You could leave out the 2 here and it'll save you a little bit of time. Okay, so I need to get this party started and I've got to calculate all of these positions. So this is going to take me a little bit of time, but I've done some work here. I know that the initial position x of 0 is equal to 4, right? They told me that. So I'm double checking to make sure that that was correct. They told me the initial position is 4. And now I've got to start calculating some areas. So if I'm at 4 and then I'm going to the left, right? I'm traveling left. I'm going to have negative, what was this area here? Well, it's 1/2 of 3 times 2. Half of 3 times 2, half of 6, is -3. So I'm going to go ahead and fill in this one first. I started at 4, and now I've moved to the left 3 spaces. That puts me at 1. Here, I'm going left, and that's also down. And so negative, negative is going to come across as a positive. Half of 6 times 3. Sorry, half of 6 times 2. Half of 6 times 2 is how much? Let me see here. Half of 6 times 2, half of 12 is 6. So I'm going to start here at 7. Okay, so let me start over here. My position is 7, right? And then this is negative. Because my velocity is negative, I'm traveling to the left. I end up at 1, and then I start getting some positive area. And at 0, I know I'm going to land at 4, right? And then I'm going to keep traveling. And so now I'm going to go from here, from -3, where I'm at 1, I'm going to have to add this area. So I'm going to add, how much do I need to add? Well, 3, because that's 3, plus, I already calculated this earlier. It was 4 minus 1/4 pi r squared. So that's basically pi. And then I keep going. As I keep going to the right, I'm getting some more positive area. I get another one of these. So now I have 3 plus 8 minus 2 pi. And then I get this little triangle of area to get me to 5. So plus 1/2. 1 times 2. 1/2 of 1 times 2 is 1. And then finally, I've got the same amount of negative area. So this becomes 3 plus 8 minus 2 pi. This area here is going to zero out that area. So I've got to try to figure out like which one of these is the biggest. Looking at all these numbers, that's 7 minus about 3. So nope. So far I'm looking at this, it's the biggest so far. 7 minus 3 would be 4. That's how much? 11 plus 1, 12 minus 6, a little bit more than 6. So 12 minus 6 be about 6. So this is still the biggest. 11 minus 6 is 5. This is my biggest right here. Particle is farthest to the right at t equals -9 minutes. Now I need to go back and read my question again. It says, when is the particle farthest to the right? When is asking us for the time value. So I've given my time value right there. Now notice this portion of the problem took me a little bit of time, right? Some of the things I could answer very, very quickly, but this was time consuming because I had to calculate all of those areas. Remember that on the actual exam, you're only going to have 4 parts to the question. So I'm doing a whole lot of parts. Some of them are very quick and fast. Others are a little bit time consuming. But someplace on the exam, you're going to have to build a chart like this, where you're going to be justifying a max or it could be a min by comparing values, okay? And sometimes you get values where you're going to have to do some approximations. Like here, I know that 7 minus a little bit more than 3, right? So I'm going to have to do some approximations. I should know the value of pi is a little bit more than 3. I should know the value of E is a little bit less than 3, because we expect you to be able to do those approximations without a calculator. Okay, we're going to keep it moving. It says, name 2 intervals of time when the displacement of the particle would equal 0. Okay, so in other words, there's got to be 2 time values where the area that's above is canceled out by the area below. So I'm looking for 2 easy ones, and I see one interval is right here. I have a time interval from 4 to 6. So 4 to 6. And you could also give this in interval notation. That would be fine. So that's one that I could see right away. Some people have trouble seeing the other one. So does anybody see the other one where there's going to be some areas that will zero each other out? On my graph right here, this triangle here, which is below, is zeroed out by the triangle that's above. And so I get a displacement of 0 on the time interval from -6 to 0. Okay. And so it just said name the two intervals. It didn't ask for any explanation. I named my intervals. I can keep going. Okay. Next, at t equals -4, is the speed of the particle increasing or decreasing, and how do you know? Okay, this is something that's important for us to know. I'm going to put it on a Post-it note. Speed is increasing if velocity and acceleration have the same sign. In other words, they would both be positive, or they could both be negative. That's how you check to determine if speed is increasing or decreasing. Some people only check one thing. Speed is decreasing if velocity and acceleration are opposite in sign. Now listen, you guys, I know that there's other ways to do this. I took physics, I know that. There's a lot of different explanations, but this is probably the fastest and easiest way to answer the question. So let's start using our graph and figuring this out. At t equals -4, is the speed of the particle increasing or decreasing? Well, at the time value of -4, I'm looking on my graph here, and I've shaded over it, but I can see that at the velocity at -4 is negative. I can see that on the graph. I can also tell you from earlier, right? Where was my earlier answer? Oh, I put on a piece of paper. Earlier, we found out that v prime of -4, which is the acceleration at -4, it was 2/3. We found that earlier, and that's a positive number. So notice I've got a negative velocity and a positive acceleration. Speed is decreasing because velocity and acceleration are opposite in sign. That is a great explanation. And notice that I'm using abbreviations here, you guys. Those are all good abbreviations. So we want you to use abbreviations that make sense and that are commonly used. And so as we go along and practice, you're going to see, the type of abbreviations that would be acceptable. You can't make up your own abbreviations. Sometimes people try to do that. They use some weird things that are like, no, nobody's going to accept that. Okay, last question for this part. If our initial position is 4, then at t equals -6, is the particle moving toward or away from the origin, and how do you know? Well, just like when you're doing this speed thing, you need to check two things. To know if you're moving toward or away from the origin, you need to look at your position. So we'll look at the position at -6, and we'll also need to look at our velocity at -6. Those are the two things that we need to examine. So I got a bunch of positions earlier. Unfortunately, I didn't get the position at -6, but I can think about it. Remember, we had 4, and then we've already said that this displacement would be 0, right? The net change in position is 0. So kind of already thought through that. So my position at -6 should still be 4, because these two areas are canceling each other out. Also, at -6, I'm looking at my graph here, and I can see that my velocity is -2. If these things are opposite in sign, then you are moving toward the origin. So moving toward the origin, because position and velocity are opposite in sign. Okay, there's my explanation. If your position and velocity have the same sign, that means you're moving away from the origin. Okay, so we've done a nice motion problem, and we did a little bit of graphical analysis. Remember, on a graph, to find the derivative, you're looking at the slope, and to find integrals, you're basically using the areas, but you need to be careful about the signs of the areas, because an integral is a signed area. Okay, so this is one type of problem that we know to expect. We're going to have a graphical analysis. We're definitely going to have a motion. They might be combined in the same problem, but they might be two different problems. Next, we're going to move on, and we're going to be doing a rate in, rate out problem. Here we go. And so this is another problem type that you should expect. Now in this one, what I know is I'm going to run out of time, because I'm only supposed to talk about this topic for about an hour, and I've got a timer here. If I didn't have a timer, I would just keep talking all day and all night, right? Yeah, the horses would be back in their stables, you guys, but I'd still be talking about calculus. So another type of problem that we know to expect that is very likely to be question number 1 or number 2, so very likely to be calculator active, is what we call a rate in, rate out problem. And so the rate in, rate out can take a lot of different forms. It can be water flowing in and water flowing out, people going in, people going out, a gravel coming into a processing plant, gravel going out of a processing plant. We've had snow falling onto a driveway, being shoveled off the driveway, sand going onto a beach, sand being pulled off of the beach. These are all really the same thing, you guys. It's a rate in, rate out type of problem. So here we've got the rate at which people enter a large store is modeled by a differentiable. Whenever you see the word differentiable, write continuous. That might be important. Function E of t, and the rate at which they leave the same store is modeled by the differentiable function L of t is given below. So we've got these two equations. And on a calculator active problem, you should get those things into your calculators. So I've gone ahead and put the equations into my calculators so that I can, go a little bit faster here. So for the sake of time, I probably am not going to answer every single one of these questions, but I'm going to set it up. Typing things into the calculator does take time, and you need to practice. You have 4 calculator skills that you need. You need to be able to graph in an appropriate window, solve an equation, do a derivative, do an integral. Those are your 4 skills. That's all you got. Everybody should be able to do those 4 skills. Okay, so before I move my calculator off the screen, I hope you guys can see my calculator. I'm hitting mode. And the reason I'm hitting mode is I need to make sure my calculator is in radians. Some of you will be taking the physics exam Monday afternoon, and you might set your calculator into degrees, and then Monday morning, you might forget to change it back. Everybody should reset their calculator every morning. That's a great way to start the day. Brush your teeth, reset your calculator, you guys, so that it's always in radians. Because in math, we only use radians, okay? So I know that's a minor detail, but at this stage, we should be working on minor details. All right, let's keep it going. We've got, we're asked for an explanation here. We've got some information. The store opens, and when it opens, there's 50 employees already that are inside the store. And then it's open over this time interval from 0 to 12. Okay, using correct units, explain the meaning. Remember, that's how we started our motion problem. Explain the meaning. We're going to have a lot of the explain the meaning, interpret the meaning of types of questions this year. We know to expect that because of the nature of this year. That's a type of question that we're probably going to see a little bit more of. Okay, so I know this is the rate of change because that's what a derivative is in E of t, which is the rate that people enter the store. So the rate of change in the rate people enter the store in Well, let's see. E of T is people per hour. And so if I do another rate on that, it's people per hour per hour. Now remember, you guys, people per hour can be written as people per hour squared. That's up to you, okay? Is this a good and complete answer? Because a lot of people stop here. Remember my thousands and thousands of papers. I want somebody to type in the chat box, like, what do I need to add to make this an actual good answer? Because right now it's okay, but it's not going to get me credit for interpretation. My time is missing. What? At T equals 6 hours. It's not hard to include that, but when you're trying to do so many different things, it's easy to leave it off too, you guys. You got to keep that in mind. You're feeling the pressure of taking a time test, but ideally, if you've practiced, you'll feel good about all of this. I always feel good in taking tests because I've prepared for them, right? And I know that even though I might not know everything on the test, I know enough that I'm going to get myself a good score. I always have a lot of confidence in myself. Sometimes it's false confidence, you guys, but that's okay. Fake it till you make it. Moving on to part B. Using correct units, explain the meaning. Oh, I recognize this bad boy too, because I just saw it a few minutes ago in the motion problem, right? We're going to check to see, do you understand that this is the average value formula? And if not, man, you need to study your Post-it note. Where's your Post-it note at? Get it out and study it, you guys, so that Tuesday morning you will recognize this as soon as you see it, or you'll be able to set it up as soon as they ask you for average value. This is the average value of E of T, which is the rate. So the average value of the rate people enter the store. In people per hour. From T equals, let's see, what's that lower limit? 3 to T equals 7 hours. I got my noun, I have my units, I have my time. Noun, units, and time, that's what's going to get it there. Okay, let's keep going. At T equals 10, is the number of people in the building increasing or decreasing, and justify your answer. So in order to check this out, I'm going to do E of 10 minus L of 10. Okay, I'm going to be typing this into my calculator. I'm basically comparing these two rates, the rate at which people enter versus the rate at which people are leaving. I don't know who that person is who's just wandering through the background. I cannot identify that man. Okay, so I'm going to use my calculator, you guys. And remember, the calculator knows function notation. I put the equations in there earlier. So I'm doing y1 minus y2. But on my paper, I wrote down the names that they're using in the test, E and L. So in my calculator, I hit alpha trace and doing my function notation. Got that? Minus, let's see, L of 10. So what's that? Alpha trace. Go to y2. Okay. And plug in a 10 there. Aha. So notice people are leaving the store faster than they're entering the store. So the number of people in the store is going to decrease. So E of 10 minus L of 10 equals negative 73.5367. Okay, notice I gave 4 decimal places. You have to have at least 3. You can give us 3 rounded, truncated, but I always just give 4 or 5 because I'm an overachiever. I want to give extra, right? So I went ahead and gave an extra decimal place because I don't feel like thinking about the rounding or messing that up. Okay. And so this is negative. So the number of people in the building is decreasing. Number of people decreasing. And this is my justification, is this statement right here. Remember that whenever you get a number out of your calculator, you need to tell them how you got it. Like, what did you type in to get this number? You should never just have like a bald number sitting there by itself. It needs to be labeled. What is it? Okay. Now we move on to the next question. And I put these 2 questions right next to each other because students have really struggled with this. we've asked this question pretty often, but we've also asked this one. At t equals 10, is the rate of change of the number of people in the building increasing or decreasing? So is the rate increasing or decreasing? Means you have to look at the derivative of the rate. This is something that really messes people up, okay? And so hardly any kids were getting this right. But this is what we're going to need to look at. So I need to compare these derivatives, basically, in order to answer this question. So remember, they're asking you if the rate is increasing or decreasing. To know if something is increasing or decreasing, you look at the sign of the derivative. So I'm going to check the sign of the derivative of this rate. So I'm not taking those derivatives by hand, you guys. My calculator has a Math 8 feature that'll take a derivative for me. You should not be taking a derivative by hand on the calculator active section. So here we go. On my calculator, and I don't know what model you'll be using. I hope that you're practicing right now with whatever model you plan to use. I need to do the derivative of alpha trace y1 at t equals 10, and then get out of that and minus Math 8, the derivative of y2, so alpha trace. Oops, what just happened? Hit the wrong key. This is what happens when it's early in the morning for me, you guys. I'm not a morning person. It's an hour earlier here in Texas, by the way. Alpha trace y2 at 10. Okay, so I typed all that in. Now remember, I've practiced a lot with my calculator. If you haven't practiced with your calculator, this is a smart move to just practice. I'm getting 26.29411. Remember, I always give extra decimal places. And this is positive, right? That's positive. And so the rate of change is increasing. Rate of change increasing. And this statement right here is my justification. I'm showing them what I'm basing this on, right? I'm not just taking a guess. I need to show them what I put in my calculator and what the result was. Then say what's special about it. The fact that it's positive is what's telling me that my rate of change is increasing. All right, let's see here. At what time are the maximum number of people in the store? How many people are in the store at that time? And we're going to justify our answer. So this is a max-min type of problem. In order to do a max-min type of problem, what I know is I need to set the derivative of the number of people in the store equal to 0. So let me do this. I'm going to start by writing an equation for the amount of people in the store. There were 50 people when we started. Those are the employees. Plus, to get the number of people in the store, you're going to integrate your rate from 0 to t. And I'm going to do E of t minus L of t. So this gives me, when I integrate this rate that they entered, will give me the number of people who've entered. And when I integrate this, it's going to give me the number of people who've left. So I had 50 people. Then this will tell me the integral of E gives me how many people have entered, minus this integral tells me how many people have left. So this is the current number of people in the store. To find a max or min, we set the derivative equal to 0. A of t minus, A prime of t, I'm taking a derivative. The derivative of 50 is 0. I don't need to show that. Then I go over here, taking the derivative of an integral. Derivative of an integral, those are inverse operations, you guys. Derivative and integral will cancel each other out, and we'll have E of t minus L of t, and I have to set this equal to 0. Remember, we need to see this equation. A lot of times, students give us the correct time value, but they don't show us the equation that gave them that time value. So we can't give you credit unless we see the equation that you have typed into your calculator. So I've got my little timer here, you guys. The timer is going off telling me that, like, hey, you need to wrap this part up and give these folks a break. We're going to take a break as soon as we finish this one part of this problem here, you guys. So there is a break coming up, and then we're going to start talking about area and volume. Even more exciting stuff is yet to come. Maybe not as exciting as today's race. We'll see. Okay. So remember, I have E of t minus L of t. I'm going to turn both of those off. I don't want to see those. I'm going to put into my calculator at y3 alpha trace y1 minus alpha trace y2. Okay. And that's all I'm going to see on my screen. Now remember, I need to set my window to look from 0 to 12. I have to have a window that matches the problem. And I'm trying to see where it equals to 0. So this is a good window for my y's, right? 0 is right in between those two. So let me just go ahead and look at the graph. Boom. Oh, I've got 2 critical points. Because I have 2 critical points, my only option is going to be to calculate, my only option for justification is going to be my closed interval test or candidates test. Remember, we did one of those earlier when we were doing the motion problem. You see how you keep seeing a lot of the same things over and over again. That's why it's kind of easy to prepare for this exam. It's so predictable. You see the same questions. Now you see them in different situations, but it's the same process, you guys. I need to find a 0 on my calculator. So my left bound, I'm just going to type in a 2. And for my right bound, I'm just going to hit a 6. Okay, I don't have to get very close. But there's one of my time values. So I'm already starting to build my chart. I'm going to have the 2 endpoints of 0 and 12. And then one of my critical points is 3.8441. And then the other critical point, second trace, the other 0. So number 2, finding a 0. The left bound, I'm going to use 6 for the left. And boy, this is just right up against the side of my my screen. So my right bound, I'm going to put in 11.9. There we go, 11.699. Now remember, there was 50 people when we started. We know that. And to calculate the number of people in the store, well, I'm going to use this equation that I already wrote down, right? I'm going to be using this amount equation that I already have on my paper. And so now, second quit, I get off that screen. I've got my 50 people plus, now I'm using my math 9 feature. I'm going to go from 0 to 3.8441. Okay. And then remember, I've already stored E of t minus L of t as y3. So alpha trace my y3. Oops. Okay. I have 186 people in the store. I'm not going to put a decimal because I'm figuring we don't have a portion of a person unless there's been some like zombie apocalypse and somebody's arm got torn off. I hope that didn't happen. Second trace. I just need to go back and change this time value. So the other critical point was 11.699. Okay, enter. How many people are going to be in the store now? Wait a second. How can we have a negative number of people? What just happened? So I must have typed something in wrong. What happened? That's not possible. So let me look at this for a second because I thought I had put all of my equations in there properly. But I did put them in there early in the morning. So let me double check. Have I got the wrong equation in here? Did I leave off a parenthesis someplace? So let me say this. When I get to something where I'm like, oh, dang, I must have made some stupid mistake, then I'm going to stop, okay? Because if you find yourself getting stuck and you're near the end of time, don't dwell on it, you guys. Keep moving. I know I would get partial credit for this because I'm showing that I have my 2 endpoints and my critical points. So I know I've typed something in wrong, and I'll go back and look for it later. You left out the LN. Thank you. Okay, somebody's pointing out. See what happens when you do stuff early in the morning? I didn't put the LN in there. So all my decimal values are wrong. right? But here's the good news. The nice thing about the AP exam is I would get tons of partial credit. All my values are wrong, you guys. Every single value I have on the paper here is wrong because I typed it in incorrectly, but I would get a lot of partial credit. Even though I have all wrong answers, I have correct methods, right? I mistype something, which happens to everybody, and it could happen to you. We hope that it doesn't. But if it does, it's not the end of the world because I would get full credit on my interpretations. I have correct methods here. And so even though I have wrong decimal values, now somebody should have typed me in the chat box like, hey, so the handout for this is available on the website, you guys. Now we're going to take a very, very short break. I'm going to go and drink some more coffee. Apparently I need more coffee. And we're going to start the next portion of this at 10:05. So everybody take a break. And at 10:05, we're going to get started and we're going to be talking about area and volume. Okay, so 5-minute break and then we'll all be back to get started again. And I apologize for my mistake. That happens to everybody. So remember that the handouts are housed at the link that's going to go into the chat box, you guys. So 11:05. So you're right. 11:05 is Eastern time, you guys. I'm still operating in Texas time. So 10:05 my time, 11:05 your time. We'll be back to talk about area and volume. Okay, everybody, welcome. And we are now in the second half of our session today. So yeah, in the last half, I made a stupid mistake. Happens to everybody. And here's the thing that I think is really important, guys. When you make a mistake, don't worry about it. Everybody makes mistakes. I have no regrets of the past. I have no worry about the future. I always try to remain in the present moment. This is a very Jedi mind trick that I've got that I want to remind you guys about as you start getting ready to take this exam. Don't be worrying about the score, right? That's the future thing. Just stay in the moment and don't worry. Like if you feel like, oh man, I think I really blew the multiple choice, don't worry about it. Move forward and just do the best that you can on the free response. I think this is a good life skill, right? No regrets about the past, no anxiety about the future. Always remain in the present moment, okay? So what we're going to be doing in this session is we're going to be talking about area and volume. There is a handout, and we'll put the link for the handout into the chat box again in just a moment. We're still letting people in. And this portion of the session, we're going to talk for obviously a little bit less than an hour. We'll finish at 11 o'clock my time, noon your time. And then remember that these sessions are being recorded. And so if you have friends who weren't able to come today, or if there's some detail that you want to go back and double check, remember that all the videos are going to be posted. And they also have the videos from previous sessions, you guys, all the videos from previous sessions. So if you are studying this weekend and you realize like, oh man, you know, I'm really having trouble with unit 7, there's a video for unit 7 that you could watch. And so remember that we have tons of materials available for everybody who wants to prepare for this exam. So thank you for being here live. We really do appreciate you guys being here, getting up relatively early on a Saturday morning. And what we're going to be doing right now is getting started talking about area and volume. And of course, I'm going to find my handout here. And so there is a handout, but you can also just take notes on paper, because I know a lot of people don't have a printer at home, and that's cool. And remember that the handouts are available. I think we've put the link into the chat box, you guys. So if you have a calculator, great. You can use that. I didn't use my calculator properly in the last session. I messed up and didn't put a natural log in where it needed to be. And so unfortunately, I had some wrong answers, but I had set up all the problems correctly. And this is the thing that we do see. It's pretty hard to get like perfect 9 points, but if you can get 4 or 5 points out of a free response question, that's considered good performance. So remember, don't beat yourself up for mistakes. Just keep going and always just do the best that you can. So area volume is a big topic. And as we go through this, I'm also going to be mentioning some strategy things that I think are important for you to know about. In this session, I'm going to do some multiple choice and some free response. So I'll talk about both portions of the exam. And so here at the front of our handout, we just have a list here of the things that you need to be able to do. So on the first page of the handout, you see kind of this listing. At the very back of the handout, you'll see a whole bunch of formulas that maybe you'll need to memorize. So you need to be able to do definite integrals to problems involving area and volume. You need to be able to set up integral expressions to calculate the area of a region between two curves. You need to be able to set up and evaluate integral expressions. Oh, am I not sharing my screen properly? Hang on. Okay. All right. So nope, just reminding everybody that all of the handouts for all the sessions are available. So some of you are probably taking statistics as well. There are videos and links for statistics, for computer science. And next week, you guys, they're having English sessions. I know some of you are probably taking the AP English exam. So like you can take advantage of all these materials, and that way you can be better prepared for whatever AP exams you're taking. Okay, back to my list here. We need to be able to do integral expressions to calculate volumes of solids with known cross sections, and that includes discs and washers. Recognize when you need to use multiple integrals. So this is the one that tends to trip people up. I have a couple of examples in here that I think are going to be helpful to you guys because that's tricky. And then also, I've noticed some students aren't familiar with being able to change a definite integral into a limit of a Riemann sum or vice versa. This is something that will definitely show up as a question on the multiple choice. Okay. It'll be either, we don't know if it'll be in part A or part B, but you will see a question like this on the multiple choice section. It's very important that you know your basic definition. So when we get to that example, I'll write the definition down. Let's go ahead and get started. I put in here kind of a thought process for how you calculate volumes. Every volume problem, you're going to integrate the area of the cross section, whatever the cross section is. It could be a triangle, a square, a semicircle. It could be a disc or a washer, but this is always the area of the cross section. And then notice that you have two basic types of volumes. You have cross sections on a base. And remember, that could be any type of figure, square, triangle, semicircle. And then you have your solids of revolution. So these are your discs and washers. As you go through the process, you've got to figure out if you're doing a dx or dy problem. So there are sort of some key things to look for to determine if it's dx or dy. And then put down your limits of integration. Do that right away because that often generates a point for you. That way, if you get stuck by the timer, the proctor calls time, at least you get that 1 point. Write down your area formula. So here's discs, here's washers. And of course, if you're doing squares, you know it's side squared. If you know it's triangles, it's 1/2 base height times height. And then here, you've got to figure out the length of your particular segment that you're interested in. So you get your integral set up and then you evaluate it if necessary. So I'm going to be demonstrating this process as we do a few of these volume problems. But this is just kind of a thought tree to kind of lead you through the process that will get you to volume. You can kind of put some arrows here if you want. Some people like to have arrows for the thought process because it's very structured process, right? This is kind of what you need to think about. And again, I'm going to demonstrate this as we get to some examples. So we're going to go ahead and we're going to do the examples. Now, I'm not going to do every problem in this packet because I only gave me an hour. So I can talk all day and all night, right? I can talk all day and all night. But here's something important, you guys. Study calculus for an hour, then go outside and walk around. And while you're outside walking around, enjoying the beautiful day, then that learning you've done is being stored in your long-term memory. It's important to take study breaks too and have some fun. So intersperse calculus, fun, calculus, fun, calculus, fun all weekend, and you're going to have a great weekend, right? After you've gone outside for a walk on this beautiful day, then, study another hour and tune into the Derby tonight, right? Maybe you're going to be part of a betting pool. I don't know, but wear a funny hat while you're watching it because that's an important part. I would say to drink a mint julep, but make sure it's not alcoholic because we have mostly underage people on here today, you guys. So definitely enjoy the Derby today because that's a fun event. And I'm so glad they're running it, right? I mean, things are starting to get back a little bit more towards normal. So here we go. I'm not going to work all the problems in my packet. I've chosen particular ones that I think will make important points. So here we go. Calculator's not allowed. So the region enclosed by the x-axis, the line x equals 3, and this curve is rotated about the x-axis. Okay, I'm going to make a very quick sketch. There's our square root curve, y equals root x. X equals 3 is a vertical line, and I'm using the x-axis as a boundary. So here is my region, right? I need to be able to make very quick sketches without my calculator. Then we're going to rotate this thing about the x-axis. So I'm already starting to think about my process. I don't need to have a really great picture here, but I'm thinking, oh, this is a volume problem. And so it is a volume by revolution. I have a horizontal axis. So this is a dx problem. So integral dx, and I'm going to go from 0 to 3. I'm following my thought process, right? So that outline that I showed you, this is what I always do. I put the limits of integration down first because on free response, if I got stuck by the timer, that would generate a point for me. Next, I need to choose my formula. Well, I can see this is solid discs. It doesn't have a hole in the middle. So I'm going to put pi radius squared, right? That's the formula that I need is pi radius squared. Next, I need to look for what I'll call the significant segment. In this problem, that's the radius. So the radius of these discs here is going to be top curve minus bottom curve, root x minus 0. Now, of course, you don't have to show that minus 0, you guys. So I've got my problem set up. And remember, on free response, you're generating points as you go. On the multiple choice, you have to get to the answer. So I should be able to integrate this very easily, right? They're not really trying to give me a hard integral. They're trying to see if I can set this up. But I also need to be able to do simple antiderivatives. Antiderivative of x is 1/2 x squared, and I evaluate that from 0 to 3. Plugging in 3, I'm going to have 9/2 pi minus, don't forget to plug in the 0. I know it's 0 in this case, but it's not always 0, right? So it's important you remember to plug in this lower limit. So 9/2 pi, I would say that this is a pretty straightforward problem. So one of the things that I'd like to say is that when we do study sessions, we often choose some of the more difficult or challenging problems to go over. And that gives you a skewed idea of what the actual exam is like. Remember, the actual exam has got a lot of easy problems. Out of the 45 multiple choice, I would classify 15 of them as fairly easy and straightforward, right? And this would be, I think, in the easier category. It's a fairly easy volume problem. But now I'm going to move on and I'm going to do something that's tricky. So I think that this is a tricky problem. And so I would say this is more like moving into the medium and hard category. And I'm going to explain why in just a second. So it's calculator. Let's see if I can use my calculator properly, because earlier I managed to mess it up. So we'll see if I can do this right. I reset my calculator all the time to just clear junk out. Okay, I like to just clear it. And so make sure that on Tuesday morning you've cleared your calculator so that you can start off with a clear calculator. And I go ahead and I put these two curves in. So here we go. I have x raised to the third minus 8x squared plus 18x minus 5. There's a curve. And then I put in another curve, which is x plus 5. And then I graph it. Okay, so depending upon how your window is set, you might not see that there's actually two areas here that are enclosed by these curves. A lot of people don't notice that because they don't have their window set properly. So let's just say, I'll show you what I'm talking about. If I had my window set like this, it's graphing, it's taking a while. But notice, like, what's going on? I'm not seeing my curve. Like, where's my graph at? And so sometimes people spend a lot of time fooling around with their windows. So hang on, I've got to stop that. Okay. And so like, oh, great, I'm not seeing much of my curve. So resetting your calculator will often give you a decent window, but not always. I'm going to show you another problem in a few minutes where, yeah, the window really messed me up. But I need to notice that there are two regions of area here. This one's really small, but there's a region there and there's another region here. So I'm going to have to do two integrals in order to get this full amount of area. I'm going to do one integral from A to B and then another integral from B to C. So let me get busy and do that. I've got to find the intersections of these two curves. So second trace, I need an intersection, so number 5. And remember that it's going to go to the nearest point of intersection. So this first region is going to go from integral from 1 to second trace. I need another intersection. So number 5 is my intersect key. Let me just move over a little bit. I just need to get it a little bit closer to that second point of intersection. I don't want to guess. That's why I have a calculator, you idiot. So integral from 1 to 2. And I noticed in this region that the cubic is on top of the line. So I'm going to be doing y1 minus y2 for this region. Plus, The other region goes from 2 over to this point of intersection. So second trace, and I need to find that point of intersection, number 5. Let me move my cursor just a little bit closer over here. Okay, that's at 5. And I'll be doing y1 minus y2. So notice I've set this up on my paper. Now I need to be careful. On the free response, I would never want to call things y1 and y2. I need to use the names that they've given it in the problem, okay? Because no one's going to know what you've entered at y1 and y2. So this is a multiple choice section where nobody's going to be looking at my work. I just want you to be careful when you're doing the free response. So let me see here. I need a math 9. Remember, practice putting things into your calculator. The more that you practice, the less likely you are to make mistakes. Well, even if you've practiced a lot, I made a mistake this morning. So alpha trace, I need y1 minus alpha trace, I need y2, x plus, I need another math 9. I'm going from 2 to 5, 2 up to 5. And this time I'm going to do y2 minus y1 because in that second region, the line was on top of my area. So alpha trace, y2 minus alpha trace, y1. Put an X in there. Okay. 11.833. So there's my answer, and then I'm going to keep it moving along. So some people think that the calculator makes things easier. It doesn't. The calculator actually slows you down. The average for most multiple choice is 2 minutes, but the average for a calculator problem is 3 minutes, you guys. It definitely takes longer to do a calculator problem because it takes time to type things in. And so that's kind of the opposite of what people think. But we've got a lot of research telling us that, yeah, the calculator slows students down. Okay, let's keep moving because I want to go over some of the things that you're going to need to know for this exam. Here we have another one where the calculator is not allowed. The region bounded by the x-axis and the part of the graph of y equals cosine x between x equals negative pi over 2 and x equals pi over 2 is separated into 2 regions by the line y equals k. Hang on. Let me start getting a picture going here. I need to know how to draw a cosine graph without my calculator, right? And they're talking about the region that goes from negative pi over 2 to pi over 2. So I'm very quickly producing graphs. So they expect you to be able to do basic graphs without your calculator. We're going to separate it into 2 regions by a vertical line x equals k. The area of this region from negative pi over 2 to k is 3 times the area of the other region. So here's my line x equals k. I'm not going to try to make it real perfect. This is 3 times as big as that. That's going to be good enough, you guys. So what's happening here? I'm going to have to set up an equation. The integral that goes from negative pi over 2 to k of cosine x dx is 3 times the area that goes from k to pi over 2 cosine x dx. Again, this is an example of a hard question, you guys. Remember, there are easy questions, but this is one that's kind of hard because I figured that's a good way for us to spend our time together today. Okay, antiderivative of cosine. Everybody should know the antiderivative of cosine is sine. And we're going to have to evaluate this from negative pi over 2 to k. And it's going to be 3 times the sine going from k to pi over 2. Sine of k minus, they expect you to know your unit circle values. That's one of the points that I'm trying to make here. If you haven't studied over your unit circle values lately, you might want to do that sometime today or tomorrow. Just get the basic values in your head because there will be some questions where you're going to have to use your basic trig values. So right here, the sine of negative pi over 2 is negative 1. Equals, over here, I'm going to have 3 times the sine of pi over 2. Now I know the sine of pi over 2 is 1, so that's 3 minus 3 sine of k. I'm having to solve this thing without a calculator, you guys. I should be able to do this. Add the opposite. I'm going to add 3 sine of k to both sides to get all the sines together. So I'll have 4 sine of k equals, right here, I've got a 1, and I'm going to subtract it over. So 3 minus 1 is 2. Divide both sides by 4, and now I need to know sine of what angle is 1/2. Sine of what angle is 1/2? Remember, we need to know our unit circle values. So I want somebody to type in the chat box. Let me make sure you guys can hear me. Sine of what angle is 1/2? And you can see you've got some choices over here, you guys. So, thank you. Thank you for everybody who's responding. It's pi over 6. Good job, you guys. And so this problem is a very nice problem. It's not just finding the area. You're having to set up an area equation and then do something else with it. And so I think it's a very nice example, and it reminds us that we need to study our unit circle values. Let's keep on going, you guys, because we have a lot to do. Number 5, we have the region of the first quadrant bounded above by the graph of y equals root x. Okay, that's one that they'd really like to use because it's fast to graph it. And it's bounded below by the graph of y equals x squared. Y equals x squared is parabola, you guys. And so we've got this. R is the base of a solid whose cross section's perpendicular to the y-axis. That's a huge hint, you guys, because when we say we're going perpendicular to the y-axis, that's a dy problem. And even if you can't do anything else, you've eliminated 2 answer choices, right? Remember, elimination is a good strategy. Perpendicular to the y-axis is telling you you're doing a dy problem. It's a huge hint in this. And we've got squares. So let me draw a square. I'm really good at drawing things. Yeah, there we go. There's my square cross section with a thickness of dy. So in order to get the length of this, I'm going to have to do curve minus curve. Well, be careful because you can't use the y equals x squared curve. You've got to solve it for x. X equals root y is the same thing. And then over here on this curve, which was y equals root x, when you solve for x, x is the same as y squared. So the bigger curve, that's the rightmost curve, is root y minus the left curve is y squared. So root y minus y squared. I know in order to get a volume, I'm always going to integrate from a to b. So I know this is 0 to 1. And then the area of my cross section times my thickness. Well, the area of a square is side squared. Area of a square is side squared. So I'm going to be integrating from 0 to 1. This side here, which is root y minus y squared, squared. Okay. Notice I need this one because this is the side of my square, and then to get the area, you have to square it. So I need choice C. That's my correct choice. Okay, let's keep going, you guys. We've got somebody in the waiting room. Okay. Now I mentioned earlier that, like, hey, the window can mess you up. And this is kind of a famous problem. It messed so many people up. It was very sad. And it caused me to panic. Now, panic is never a good strategy, you guys. Panicking is just a reaction to, the possibility of a future event. Again, always stay in the moment. So I want to show you what I did that was stupid in retrospect, but at the time, I wasn't as zen as I am now. So I put this function into my calculator. Okay. Got my function in there properly. And I'm trying to find the area of the region. and the first and second quadrants bounded above by this graph and below by the horizontal line y equals 2. So let me put in y equals 2 also. R is the base of a solid whose cross-section is perpendicular to the x-axis or semicircles. What is the volume of this solid? Okay. The original problem was a free response question. We've just changed it to multiple choice for today. So I graphed it. I put these in and I graphed it. And when I saw the graph, I panicked. Because when I looked at this graph, I thought, oh my gosh, there's a vertical asymptote at 0. Do you see how the graph is going up? Right? I thought, oh my gosh, there's a vertical asymptote. That is so messed up. You know what? There's no vertical asymptote, you guys. Once I calmed down and I looked at the equation, I'm like, wait a second, no, there's not a vertical asymptote. The graph goes up to 20, right? The y-intercept is at 20. I just can't see it on my screen. And so remember, one of our 4 calculator skills is setting an appropriate window for the problem. The window I have here is not appropriate, okay? It's not appropriate for my problem because it's making me panic and think that there's an asymptote when there's none. Now, a lot of people misread this and they got everything wrong that you could possibly get wrong. Some people thought the areas were these 2 pieces, kind of like a little mustache. Some people thought the area was this thing right here. But no, it's this area that you don't see the upper boundary right now. So let me fix my window so that we can see what's going on. We don't really need to go all the way down to -10. We'll just go -1, and then we'll go up to 22 because the top of the graph is at 20. Okay. So the bounded region is this region right here. And now you're seeing why using the calculator does not make you go faster. It can actually slow you down. And so this particular problem was a very time-consuming problem, not because like the math was hard, but using the calculator was kind of challenging. So remember, the region that we're interested in is this region right here, okay? And so I need to get my limits of integration. So it's going from here to here. So I'm going to very quickly find the intersection using the intersect feature of my calculator. And remember, practice with your calculator. I don't know what model you're going to be using for the exam, but whatever it is, make sure you practice. Intersection is at 3, 2. So this integral is going to go from -3 to +3. I can see that there's symmetry there. I don't need to find the other point of intersection. So I know I'm going to integrate from -3 to +3. My cross sections are semicircles. So there's my significant segment, and my semicircle, that's that bottom piece that I need to get. Well, I know it's top curve minus bottom curve. So this all the way across is going to be 20, 1 plus x squared minus 2. We always do top curve minus bottom curve. That's how you set it up to find the length of this segment. Now I need to do the area of my cross section. The area of my cross section is going to be semicircle, so 1/2 pi r squared. Unfortunately, this is not the radius, you guys. This is a diameter. Darn diddly darn. So my radius, if I just chop this in half, my radius is going to be 10 over 1 plus x squared minus 1. So for my integral, I have 1/2 pi radius, which is this, 10 over 1 plus x squared minus 1, and I have to square it. Now, I'm not going to take the time to put this in my calculator right now because I know I'm going to run out of time and I want to get to some of my free response questions. But notice what I'm doing. I'm reminding myself that when I put this in the calculator, I need to put parentheses. I got my parentheses right this morning, and then I stupidly forgot the natural log that I needed to type in. I'm hyper careful about parentheses, but you got to be careful about everything. And it takes time to type this stuff in. So if I realize that the clock is running out and I can see that I have a calculator problem and a non-calculator problem, I might skip the calculator problem, do a guess and go if I need to. So it's important to know, like, when you're getting towards the end of the exam, and if you're going to run out of time, make sure that you don't just leave things blank, right? At that very last minute, right before the proctor says, put your pencils down, bubble in answers for everything, right? If you see you're going to run out of time, go ahead and bubble them in, because you might be able to get one of them right. Okay, let's keep going, because I have a lot to talk about and I have limited time. Unless I can convince you guys just to stick around, you know, for an extra hour or two, we could do all the problems in the packet. But I'm trying to choose the ones that are particularly tricky. Remember, by choosing the ones that are particularly tricky, I'm making this exam look a little bit harder than it actually is. So remember that there's going to be a variety of questions, some easier ones, some that are kind of medium, and then you'll get hard ones like this. The functions f and g are given by, and notice this is calculator not allowed, so they expect us to be able to draw these really easily. So I have a square root function. They like to use that one a lot because students can draw it quickly. And g of x is x minus 3. So y-intercept of -3 and a slope of 1. So get something like that. Let R be the region bounded by the x-axis, okay, and the graphs of f and g. Okay, so it's basically this weird shape right here. The graphs of f and g intersect in the first quadrant at the point 9, 6. Look how nice they are. They're helping me. They're giving me this value here of 9, 6. Which of the following is the volume of the solid generated when R is revolved about the x-axis? So I'm going to spin this thing around, and I'm going to be getting, you know, some kind of weird solid. Now, this is a super tricky problem, you guys. Okay, this is an example of something that I think is pretty difficult. A lot of students don't notice that when you go to revolve it and you're trying to draw in your radius, so notice that we're going to be doing a disk method. We're going to have solid disks, but the radius changes. If you're over here, your radius goes from the root curve down to the x-axis. But if you're over here, right, we're going to start getting a hole in this thing. We're going to switch from a disk over to a washer. This is combining a disk and a washer situation. So I'm going to draw the rest of this thing out. Okay. And this thing looks like a Pac-Man. So anybody ever played that game, Pac-Man? Goes along and eats those dots. That was a very good game. But notice that I'm having to split this up and do two different integrals. I'm going to start with a disk method from here to here, but then when I get over here, I'm going to have a washer method. I'm going to have two radii. One is going to go here. That's one radius. And then another radius is going to be this white empty part, right? That's what creates the hole in our figure. So over here, we have a washer method. There's a hole in the middle. Whereas over here, we have a solid disk. And so this is one of the things that's very tricky when you have to split it up and use two separate integrals. So right away, like, these choices are out, right? Even if I can't do anything else, then I'm going to narrow it down to these two. Then notice this front part is the same. So like, I don't care about that anymore. The front part's the same. Let me focus on this part. This is a washer method. So in a washer method, I'm going to have pi integral, and it goes from 3 to 9. Like, that's the same, so I don't need to worry about that. But remember, it's r squared minus r squared dx. My big radius, the big radius is the distance from 2 root x down to 0. So 2 root x minus 0. And my little radius is this line here, minus 0. Now, of course, I'm not going to show those minus zeros. But notice, when I square this big radius, I'm going to have pi integral from 3 to 9, and I'm going to have 2 root x square it minus the little radius squared dx. So I need this one, right? This is the one that I need. The wrong answer here, this is wrong, right, is doing r minus r and then squaring it. That never works, you guys. but that's always the distractor, right? The correct formula is this. This is the wrong one that a lot of students try to use, right? Be very careful. But the way we make these distractors is very consistent. We know students subtract the radii and then square it. That does not work. The way to do it is to square each radius individually. That's how you do a washer method correctly. So we know how to anticipate your mistakes, and then we build all the distractors, the wrong answers, around the common mistakes. Okay, finally, we're getting to a problem that I promised you guys. I think it's very important for students to know how to convert a definite integral into a limit of a Riemann sum. This is the definition of a definite integral, and a lot of students don't have it memorized. In the first session this morning, I said, hey, you guys, I write stuff on Post-it notes, and then I post it around my house, or I carry it with me so that I can memorize it. If I have a definite integral from a to b of f of x dx, and I want to convert that to a limit of a Riemann sum, this is a formula or a definition. It's f of a plus delta x times I times delta x. Right? This is the definition of a definite integral. And to get your delta x, you do b minus a and divide by n. Okay, so this is a definition that everybody should know. And I'm thinking there's a few of you out there that don't know it. Okay, if you don't know this one, type in the chat box and say, I didn't know that, because it's something that they're going to test you on. There's going to be at least one question on the multiple choice. So remember, as you're studying and you're trying to learn a definition, formula, or theorem, in your brain, you need to be thinking, oh, that's another point on the AP exam. That's another point on the AP exam. And if you can accumulate 40 to 50 points, you're going to have a 3 on the AP exam. And if you can get a little bit more than 70 points out of the 108 that are available, that'll give you a 5 on the AP exam. So in this particular problem, right, they're saying which of the following limits is equal to the area between the graph of this function and the x-axis from 1 to 3. So like just a very quick drawing. This is 1. This is the natural log graph. And so they're basically taking this integral and they're wanting me to convert it to a limit of a Riemann sum. So I need to very quickly remember, like, oh yeah, here we go. Here's the definition. And the easiest thing is to get your delta x. Get that first. My delta x is going to be 3 minus 1 divided by n. So 2 over n. And notice how this is outside the parentheses, the 2 over n. So right away, I'm like, okay, this is out and that's out. I've eliminated 2 choices very, very quickly. Now, as I look at my definition, I need to remember we have to plug in a 1 because this problem starts at 1. And so as I look at these 2 choices, oh, this one, they've got 1 plus, there's your delta x. And instead of I, they're using k. That's all right. K is a good letter too. K for Kentucky, you guys. So I think that K, J, and I are all letters that are kind of interchangeable here. And so throwing in a different letter shouldn't bother me. I should still be able to recognize my definition of a definite integral. So I think it's interesting. Nobody's typed at me and said that they didn't know that. Usually that's one of the formulas that a lot of people haven't learned. And so I'm glad to see that, like, okay, people seem to know this. That tells me you're going to be in pretty good shape for the exam on Tuesday. Let's keep going. And I want to see if I can get to my free response questions, because I know I have 11 minutes left, you guys. A little bit more than 11. And here we are on a free response question. Okay. So this was a question that I really enjoyed. I remember the day that the kids took the AP exam, I was eating at Chick-fil-A. I like Chick-fil-A. I think they're a pretty cool company. And this kid comes up to me and he's like, hey, you're a calculus teacher. And I'm like, wow, I really look like a calculus teacher that some random person at Chick-fil-A would stop me and say, you look like a calculus teacher. Well, I was wearing a calculus t-shirt, so that kind of gave it away. I have a big selection of calculus t-shirts, by the way. And so the student stopped and said, hey, I just took the AP exam this morning, And there was this crazy funnel problem. And I was like, funnel problem? Of course, we hadn't seen the exam at that point. He said, yeah, it was a problem. It was all about a funnel. I couldn't figure it out. And I was like, oh, okay. All right, so let's look at this funnel problem. And we're not going to do the whole thing. We're going to do these two parts right here. Notice it's a calculator not, oops. It's a calculator not allowed question. We're not going to use a calculator on it. This is one we'd have to do by hand. First thing says, you know, it describes it, the inside of a funnel, it's 10 inches, height of 10 inches, has circular cross sections. That was a big hint that there's going to be circles involved here. Shown in the figure above, at the height, h, the radius of the funnel is given by, where h goes from 0 to 10. The units of r and h are in inches. First thing says find the average value of the radius of the funnel. So earlier today, you guys, I made a post-it note for average value because I said this is a formula that they expect you to know. And we're going to test it on the multiple choice and on the free response. We have to. We got to find out if you know this. And so learning this one formula can generate 3 or 4 points on the AP exam. That's what you want to do, is you want to go for the things that are high dollar value. What'll get you a lot of points? Knowing this average value formula is kind of a big deal. So the average value of the radius, I know in order to get an average value, I'm going to add and divide. What am I trying to find the average value of? This radius right here. So I'm going to go ahead and put the 1/20th here. And then I have 3 plus h squared, dh. And then my h is going from 0 to 10. So 0 to 10 and then 10 minus 0. That's how I would write it. And this is going to get me some credit just for setting it up, right? This is set it up and they're going to give me some points right away. So I'm excited about that. And now I'm going to have to calculate this by hand. Now I can do some math correctly. 1/20th divided by 10 is 1/200th out front. What I'm needing to integrate is this 3 plus h squared. That's what I have to do the antiderivative to. So I have the 1/200th out front. The antiderivative of 3 is 3h, and the antiderivative of h squared is 1/3 h cubed, 0 to 10. I'm going to plug in this 10. I have 1/200th. 3 times 10 is 30, plus 1/3 of 10 cubed, minus, I know if I plug in 0, I'm getting zeros. And remember, I'm stopping there. As soon as I have numbers, I'm at a safe stop. So on the multiple choice portion, yeah, I have to do arithmetic. So it's important that I know how to do arithmetic. But on the free response, as soon as you get to numbers, you should stop. You should not go any further because you don't get any more credit. And there's a chance I could make a silly arithmetic error. I don't want to lose a point that I've already earned. If I stop here, I've earned the point, right? If I go further and make a mistake, they can't give me the answer point. And so we have to get in the habit of stopping. That'll allow us to move on to the next part of the question. Yay. The next part is the part that's relevant here. Find the volume of this funnel. Students could not seem to understand. All you're doing is a disk method here. You're going to add up a whole bunch of circular cross sections as h goes from 0 to 10. So it was kind of a non-traditional volume problem, but it wasn't that hard. We're doing pi integral from 0 to 10, our radius squared dh, because the variable here is an h. That's what was throwing everybody off. So I'm going to have to plug this in, right? Need a little bit more space. So I'm going to plug in my radius, which is the 1/20th. 3 plus h squared, close it and square it. Okay, so I've got this set up, right? This is set up correctly. I need to make sure I have enough parentheses. I'm always very paranoid about my parentheses. This is the radius, and I'm squaring the whole radius. This is the setup, and I get a lot of points for setting it up. Now I'm supposed to go ahead and work it out. And I'm gonna work this out because I want to talk about the common mistakes. Here are some common mistakes. Some people forgot to square the 1/20th. right? 20 squared is 400. I know that. So I'm going to have pi, and that becomes 1/400. And then in order to do this integral from 0 to 10, I need to square this out. The only way you can do the antiderivative of this is to square it and then integrate each of those three terms. Notice I said three terms, because when you multiply 3 plus h squared times 3 plus h squared, you get 9 plus 6h squared plus h to the 4th dh. A really common mistake that students made is that when they squared it, they thought they could just square the 3 and square the h squared. They only gave us those two terms. So I need to be able to rewrite things using algebra, so then I can do my calculus on top of that. I've got a pi over 400 out front. Then my antiderivative is 9h plus add 1, h cubed, 6 divided by 3 is 2. Add 1, h to the 5th, 1/5 out front, going from 0 to 10. Okay, pi over 400, that's 90, plus 2 times 10 cubed, plus 10 to the 5th divided by 5, minus, if I plug in a 0 there, I'm going to get 0, you guys. So I just put my minus 0. And I'm done, right? There's my safe stop. The students who did all the arithmetic never had time to get to part C, because they spent all their time doing 10 to the 5th and dividing by 5, and often they made some kind of silly mistake. Too many students spend time doing arithmetic, and that's not how you should spend your testing time. You need to spend your time doing your algebra correctly, right? Squaring a binomial properly, and then doing these antiderivatives. That's calculus stuff that we need to show them. As far as arithmetic, we want you to be able to do arithmetic properly, but it's not the main focus of this exam. So we really, really need to be focusing on the things that are going to generate points. Okay, let me keep going. I'm going to at least start this next problem. I'm not sure if I'm going to have time to finish it, but we're going to give it a go because I like to. Okay, here they've given us a graph. I like it when they give us a graph. And let's see, this calculator is not allowed on this, so I'm going to have to do everything by hand. The functions f and g are given by, and we've got the square root graph that we've seen a lot today, and then we have this line right here. Let R be the region bounded by the x-axis and the graphs of f and g as shown in the figure above. Find the area of R. Now, let me tell you that there's multiple ways of doing this, you guys. There's several different ways that are all correct, and some of them are pretty clever. But I want to do the easiest thing that I can. And probably the easiest way to find the area of region R is to break it up. Find the area of this region, and then add this region over here. So the area of region R is going to be the integral from 0 to 4 of root x, which I'll write as x to the 1/2 dx, plus, well, now you have a choice. You could do calculus, or you could notice like that's a triangle. And so the area of that would be 1/2 of 2 times 2. So you've got choices that are both good choices. You don't have to use calculus all the time. There are times where geometry is the better choice. Now, notice here, like this is a pretty easy antiderivative. Add 1, we get x to the 3/2. Dividing by 3/2 is the same as multiplying by 2/3. Okay, 1/2 of 4 is 2. Right here, again, I can do a safe stop if I don't want to worry about like taking the square root of 4 and cubing it. I have 2/3 of 4 to the 3/2 power minus 0, because I always plug in the 0, plus 2. Safe stop, let's keep it moving, because I wanted to get to this problem right here. The region R is the base of a solid. For each y between 0 and 2, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose base lies in R and whose height is 2y. Okay, there's a lot of hints here. The fact that you're perpendicular to the y-axis is telling you this is a dy problem. So I'm going to have integral I'm going to let them know that, yep, I caught that it's a dy problem, and I'm going from 0 to 2. That alarm is telling me I have 5 minutes, you guys. So I want to finish this problem, and then I'm going to give you some final pieces of advice before we close out for today. Notice that if all of a sudden the timer goes off like it just did, that would get me a point. Remember, you guys, keep working until the proctor says stop. And then after that, go out and do something fun to celebrate. Because you will have completed this task. That was a really difficult task this year, but you did it. Like, you should have an amazing feeling of achievement no matter how your score turns out. The fact that you're going to go and sit for this exam is a huge advantage to every single one of you. So don't worry so much about the score, right? Get in there and play the game as hard as you can, right? Run your race as hard as you can. Every horse today in the Kentucky Derby is kind of a winner because they're at the Derby. And there's a lot of people that are not going to be at the Derby. There's a lot of you that are going to be sitting for this exam. And that's going to be a huge victory in itself. Okay, so perpendicular to the y, that's really important because it's a dy problem. And even if this is all I get, I would get some partial credit. But now I need to go up here to my equations, and I need to realize that my significant segment is running from here to here, right? That distance right there is the bottom of this rectangle. I know the height of the rectangle is 2y, but I need to get this base region. So I'm looking at the graph, and I know I have to go from curve to curve. The issue is you can't use this, y equals 6 minus x thing. Y equals 6 minus x does not help us because we need to do everything with y's in it. So I need to solve for y. I'm going to add the x over and subtract the y. So x equals 6 minus y is that curve. And then this curve, which was y equals root x, if I solve for x, is the same as x equals y squared. So when I go to do curve minus curve, it's 6 minus y minus y squared. It's right curve minus left curve. Bigger minus smaller always. So I've got 6 minus y squared is the base. And then I've got my height that they gave me. I know that the area of my cross section is base times my height. And now I have some more credit. Now notice it says write, but do not evaluate. You need to make sure you're following the instructions because I was getting ready to work this out, right? I was going to work that out and waste time that I could probably use if I had one more question to do. We don't because we're done for today in terms of all of the practice. But my final point is make sure that you're reading the instructions very, very carefully because sometimes students don't pay attention to what's being asked. It says write the integral expression that gives the volume. It doesn't tell me to work it out. So like this is good enough. I need to stop right here. So final words. I want to say thank you guys to everybody who showed up today, first of all, because you're taking your time to do a little bit of extra practice to be prepared for the AP exam. We hope that you're going to share this information with your friends because I think that math should be a social experience, though this year it's having to be socially distanced, right? So it changes it up a little bit, but that's okay. Sit 6 feet apart and work a bunch of problems, right? Yell answers across the park to each other, however you're going to do it, but get together with some of your friends and study with them. And so I'm going to ask you guys again, I'm hoping somebody will type something in the chat box. I like the chat box feature sometimes. So I want you guys to say something, just type something in there that you learned today that you didn't know before, that you're going to share with your friends, something that you heard, and it can be something small, something that you learned on the calculator, some advice, anything at all. Type something in the chat box like that you plan to share with your friends this evening or tomorrow or on Monday as you do your final study efforts. Because we hope that you guys are going to study really, really hard for this exam. And then after you've prepared well and you've taken the exam, then go out and do some fun stuff. So some people are saying they learned about a safe stop. Watch out for the window on the calculator. Yep. Noun, unit, and time. That's a great way to remember how to do the interpretations, right? always set up the answer and work until the end. Stay until the end of the test. I understand the cross sections part. Don't worry about the score. Don't forget about your units, okay? So remember, like, I was never a great athlete, but I really do believe this. It's all about playing the game, you guys. Like, I wish that I could have been on some kind of athletic team. It looks like it'd be fun, but I don't have that talent. But playing the game is fun anyways. I don't have to be in the NBA to enjoy shooting some baskets. So that's what I'm going to do next. I'm going to go down to the park and shoot some baskets and have a good time today. Enjoy being outside for a little bit. Then I'll come back and I'll do some grading. I'll do some calculus. And I want you guys to do the same thing. Go have a nice Saturday. Enjoy something. Study a little bit more. Watch the Derby. Study a little bit more. Keep the study efforts going until Tuesday. And then by Tuesday, I want you guys to have a great day. May the 4th be with you, okay? It will be Star Wars Day. So I have a really fantastic skit planned for my students. I'm very excited about this. I have a costume and a lightsaber and a lot of other props too. So thank you guys for being here. And thank you for Advanced Kentucky for sharing this with everyone, making it available to every student, you know, who's going to be taking the exam. We really do appreciate your efforts. Okay, Advanced Kentucky, I throw it over to you. Some final words for you.
Thank you so much. Thanks to everyone at home for joining us, and a huge, big thank you to Dixie Ross. This was so much fun today. Thank you for volunteering your time and talent and efforts. We really enjoyed it today.
Okay, guys, have a great Derby Day.